In 6th grade math, one of our major goals is to achieve fluency with the standard division algorithm. Fluency doesn't just mean getting the right answer. It means getting the right answer quickly and confidently using a reliable method. The standard algorithm, or long division, is that reliable method. We'll be dividing multi-digit whole numbers, so you need to be very comfortable with your multiplication and subtraction facts. Before we dive in, let's make sure we all use the correct vocabulary. The number you are dividing up, the total amount, is the dividend. It goes inside the bracket. The number you are dividing by is the divisor. It goes outside. And the answer you get is called the quotient. It goes on top. If there's anything left over at the end, that's the remainder. Knowing these terms helps you understand the steps of the algorithm. The standard algorithm is just a repeating cycle of steps. D, M, S, B, R. Divide the divisor into the number. Multiply your quotient digit by the divisor. Subtract that product from the number you divided. Bring down the next digit from the dividend. And then you repeat the process until you run out of digits or you write the remainder. Memorizing DMSBR is the secret to successful long division. Let's apply the steps to our first problem, 368 divided by 4. First, 4 doesn't go into 3, so we look at 36. Divide. 36 divided by 4 is 9. We write 9 over the 6. Multiply. 9 times 4 is 36. Subtract. 36 minus 36 is 0. Bring down the 8. We repeat. Divide 8 by 4 is 2. We write 2 over the 8. Multiply. 2 times 4 is 8. Subtract. 8 minus 8 is 0. The final answer, or quotient, is 92. Now let's work through example 2, 435 divided by 7. We start by dividing 43 by 7. Divide. 7 goes into 43 6 times. We write 6. Multiply. 6 times 7 is 42. Subtract. 43 minus 42 is 1. Bring down the 5. We repeat. Divide 15 by 7 is 2. Multiply. 2 times 7 is 14. Subtract. 15 minus 14 is 1. Since there are no more digits to bring down, 1 is the remainder. The answer is 62R1. A great habit to build when aiming for fluency is checking your work. The check is simple. You multiply the quotient by the divisor and then you add the remainder. The result should be the original dividend. For example 2, we check 62 times 7 plus 1. 62 times 7 is 434, plus 1 is 435. Since 435 was our original dividend, our answer is absolutely correct. In 6th grade, we often move beyond just writing R1 for the remainder. We can express the remainder as a fraction. To do this, you simply take the remainder and place it over the divisor. In our last problem, 435 divided by 7 had a remainder of 1. So, we express the answer as the mixed number 62 and 1 over 7. This gives a more precise answer. When you deal with larger numbers, it's easy to make a small error. That's why estimating is important. Before you even start dividing, round the dividend and the divisor to get a quick idea of your final answer. For example, if you have 815 divided by 40, you can round that to 800 divided by 40. That result is 20. If your final answer is anywhere near 20, you know you're on the right track. Let's try a 2-digit divisor in example 3, 748 divided by 22. Using our estimate, we know the answer should be around 35. We look at 74 divided by 22. We can try 22 times 3, which is 66. We write 3. Subtract 74 minus 66 to get 8. Bring down the 8. Now we have 88 divided by 22, which is exactly 4. Our final answer is 34. This is very close to our estimate of 35, confirming our fluency in the algorithm. When performing long division, The place value of the quotient digit is everything. If the divisor does not go into a certain number, you must write a 0 above that digit in the quotient as a placeholder. If you skip this 0, your entire answer will be shifted one place value to the right and will be 10 times too small. Zeros ensure your final number is correct. Example 4 shows why zeros are needed. 5,208 divided by 8. 8 goes into 52 6 times. We write 6. We get a remainder of 4. We bring down the 0 to make 40. 8 goes into 40 5 times. We write 5. We get a remainder of 0. We bring down the 8. 8 goes into 8 one time. We write 1. The final answer is 651. Notice there was no 0 in the middle here because the divisor went into all the numbers. Let's see the zeros appear in example 5. 12024 divided by 4. We start with 12 divided by 4 equals 3. We write 3. Now we bring down the 0. Divide. 0 divided by 4 is 0. We must write the 0 in the quotient. Bring down the 2. Divide. 2 divided by 4 is 0. We must write another 0 in the quotient. Bring down the 4. Now 24 divided by 4 equals 6. The final answer is 3006. Without those two zeros, the answer would incorrectly look like 36. Long division helps us solve real-world problems that involve equal sharing. When a problem asks, how much does each person receive, or how much is in each section, you know you need to divide. You take the total amount and divide it by the number of people or groups. The quotient tells you the exact amount per group. Word problem 1 is a classic sharing problem. A prize of $1,875 is split among 15 students. The setup is $1,875 divided by 15. When you go through the standard algorithm, you find that 15 goes into 18 one time with 3 left over. Bring down the 7 to make 37. 15 goes into 37 2 times with 7 left over. Bring down the 5 to make 75. 15 goes into 75 5 times. Each student receives $125. Another type of real-world problem is finding the number of groups. Here, you know the total amount and the exact size of each group, and you need to know how many groups you can make. The setup is still division. The total amount divided by the size of each group. The quotient tells you the number of groups. Word problem 2 is about finding groups. A factory produced 5,136 parts, and each box holds 24 parts. The setup is 5,136 divided by 24. After working through the algorithm, you'll find that 24 goes into 51 2 times. After subtracting and bringing down, 24 goes into 33 one time. Finally, 24 goes into 96 4 times. The factory made 214 boxes. Sometimes the remainder is the most important part of the answer. Take the scenario on the slide. 25 kids need to ride in cars that hold 4 kids each. 25 divided by 4 equals 6, with a remainder of 1. This means you need 6 full cars, but you still have 1 child left over. To solve the real-world problem, you actually need 7 total cars, 6 full ones, and 1 more for the single child. Always think about what the remainder means in context. Let's tackle a 3-digit divisor in example 6, 1650 divided by 110. This may look hard, but we can simplify by ignoring the 0 on both numbers for a moment. 165 divided by 110 is 1. We write 1. The remainder is 55. We bring down the 0 to make 550. Now, how many 110s are in 550? If you think of it as how many 11s are in 55, the answer is 5. So, the quotient is 15. Remember, Achieving division fluency isn't about memorizing every answer. It's about mastering the process. Practice the DMSBR cycle until it becomes automatic. Always focus on lining up your digits correctly to maintain accurate place value. If you consistently apply the standard algorithm steps, you will be able to solve any multi-digit division problem quickly and accurately. Here is your final challenge. 19,584 divided by 32. Take your time, estimate first, and follow the standard algorithm step by step. Go through the DMSBR cycle for each digit. You will find that this problem has an exact quotient with no remainder. Master this, and you'll be fluent in dividing multi-digit numbers.